Okay, so we are in section 6.2, and we're going to actually take everything that I was talking about yesterday, where you learn how to spin in a certain direction. We're going to be doing that. We'll stop in a particular quadrant, like if it says spin to 60 degrees, and remember, they're going to speak to you in two different languages. Sometimes they will tell you where to spin in terms of degrees, and sometimes they'll talk about it in terms of radians. So the first thing you need so that you can spin to the proper place and draw your right triangle is you got to know what they're talking about. So let's make sure that you're real comfortable with the angles that they are going to be mentioning very, very frequently. Those would be pi over 3, pi over 6, and pi over 4. So for a while you might have to think about it, but really, you'll see that you're going to be able to do this in your head very quickly. Think about it. Pi is the same thing as 180, right? 180 divided by 3. Doesn't 3 go into 18 6 times? So this would be 3 goes into this 6 times with an additional 0, 60. That's where that comes from. So if you take 180 and divide it into just 3 parts, each of those 3 parts is pretty big, 60 degrees. So if I tell you to spin to pi over 3, because you're going to see I'm going to start off by telling you what quadrant to spin to. If I say spin to pi over 3, you're going to spin to 60 degrees. You're going to see that in your head automatically. Degrees will be your default language. You'll be, right away, somebody will give you something in pi and you'll convert it into degrees in your head like automatically, probably without even thinking about it. And you want to be at that point where you're interchangeably being able to think about the two of them. If I talk about pi over 6, again, if you think of that in an arithmetic sense, it's 180 divided by 6. 6 goes into 18 3 times, 3 with an extra 0 on it, 30 degrees. So the reason that it's a tiny angle now, smaller than this, is because you're chopping it up into 6 pieces, not just 3. The less pieces you chop it up into, the bigger that is. But whatever, you don't even have to know all that. Just you have to know how to do simple division. You want to plop that in your calculator every single time I give you a radian type number, do that. But you're going to see you'll be able to just like interchangeably very soon know that this is 60. Divided into 6 parts, it is 30. Likewise, same type of reasoning, 180 divided by 4 is 45. These are the 3 angles that you are going to see me use endlessly until we finish this class because they relate to what you learned in geometry. You learned in geometry about triangles, right? Almost the entire study of geometry is triangles, or at least it's like 2/3 of the class. And a big thing that you talk about in there is right triangles. And right triangles can come in 3 different forms when they're called special right triangles. If it's just like a generic right triangle, then all you got going for yourself is Pythagorean Theorem. However, and you have to know, when you use Pythagorean Theorem, I'm sure all of you are very well versed in Pythagorean Theorem. We'll be using it a lot, but we'll be using, more often than Pythagorean, we'll be using special right triangle formulas. But since we're always going to be working with either 30, 60, or 45 degree type right triangles, those are what we call the 3 special right triangles, I'm going to try and get you to memorize the sides. Now with any of the right triangles, whether it's a 30 degree right triangle, a 30, 60, 90, or whether it's a 45, 45, 90, there's a certain relationship between the 2 legs and the hypotenuse. So I am going to tell you what the relationship is, but I'm going to suggest that, that you memorize these values. Now, I am going to start off these triangles by picking a value. I'm allowed to pick whatever I want. I'm going to pick the easiest number I can think of as my starter value. And when I talk about starter value, what I'm saying is that in these right triangles that I'm going to introduce to you right now, remind you of from geometry, that there will be one leg or one particular piece that you can get all the other pieces from. And that is the one that I'm going to arbitrarily choose some value for. So while this might not match what your high school teachers told you, it is what I consider the easiest way to do it. So let me remind you of these 2 triangles called the 30, 60, 90 and the 45, 45, 90, because we're going to be using those. Everything that you spin to and then end up drawing is going to result in either a 30, 60, 90, a 45, 45, 90, or sometimes I'll tell you to spin to a place where you won't be able to draw a triangle at all. Those are called the quadrantal angles. Okay, so first type of triangle that I need for you to get in your memory is called a 30, 60, 90. Now I'm going to draw it this way. They can point in any direction you want. Okay, you're always going to have a right angle. This is all about right triangles. One of them is going to be a 30, and one of them is going to be a 60. This is one of the special right triangles. There's only two of them, like I said. There's the 30, 60, 90. There's the 45, 45, 90. So special right triangles. This is one of them. Okay, here's the relationship that the legs and the hypotenuse will have for this particular type of right triangle only. Okay, you're going to see that every single time you have a triangle like this. Now, if you don't remember this, let me remind you of some things. In a triangle, do you see how we have three different angles inside, and one is the smallest? Then there's one that is the medium-sized angle, and then there's the one that's the biggest, which is the 90-degree angle. So this is called the Triangle Inequality Theorem. The sides relate to the angles in this way. The longest side is across from the biggest angle. So now what is the longest side here? Give me a name for the longest side here. Hypotenuse. So you know that the hypotenuse is the longest side, and it is across from the biggest angle. Across from the smaller of these two acute angles, those are called acute angles when they add up to 90. So that is a complementary, that's a complementary pair. They add up to 90, and each one of them is less than 90. But together they add up to 90. So across from the smaller acute angle is what we call the short leg. And across from the bigger acute angle is the long leg. And so when teachers talk to you about the relationship of the legs to the hypotenuse, and you're doing a special right triangle, they will refer to this as the short leg, long leg, hypotenuse formulas. Okay, in this particular triangle, the hypotenuse is always, everything's based on the short leg, by the way, in the 30, 60, 90. Hypotenuse is always double the short leg. Let's call this the short leg, because it's across from the 30. The short leg will always be located across from the 30. This picture is not drawn true to form, so it doesn't have a real life perspective on it. Okay, 60, this will be what's called the long leg. The formula for long leg is, it'll be the short leg times square root of 3. So knowing that this is the case, what I think that you should do, since everything is based on the short leg, and you're allowed to choose, pick something as your starter value. The starter value should be the thing that everything else is based on, which is the short leg. And you can let it be any number you want. You can let it be 1/2. You can let it be 10. You can let it be 5. You're definitely not going to let it be a negative, because the sides, they refer to how long something is, and you don't tell somebody, hey, I live -5 miles from the school. So when you're talking length, it has to be positive. Smallest number I can think of that is non-fractional, not a decimal, 1, the number 1. Let's let the short leg be 1. Then based on these formulas, the hypotenuse is double. See, you're not even using Pythagorean Theorem. These special right triangles, you can do the values right in your head. And then the long leg is just take the short leg, multiply it by square root of 3. Okay, 1 times square root of 3, square root of 3. This will always be the relationship in a 30, 60, 90. Try to commit those to memory. The short leg is the one that you can let it be whatever you want. Now, in high school, teachers are very keen on letting that short leg be 1/2, just because that's the way they write it in the books, but you can let it be whatever you want. Just as long as the relationship between the short leg, the long leg, and the hypotenuse stay true to those two formulas that I gave you. Okay, then there's only one other kind of right triangle that's considered a special right triangle. That's the 45, 45, 90. So let's put that one down here as well. And you can label this the 30, 60, 90 scenario. And then this one will be the 45, 45, 90. Okay, let's just draw another right triangle. Put a 45 here and a 45 here. Again, this picture is not true to scale. I'm just trying to give you what the basics are for these two types of triangles. Okay, back to the triangle inequality theorem. I did just say that in any triangle, I don't care what kind of triangle it is, the longest side is always across from the biggest angle. The medium side is always across from the medium angle, and the small across from the small. Short side across from the smallest angle. Now, do you see in this particular problem that still the longest side would have to be the hypotenuse, right? Because isn't it the biggest angle in the whole triangle? So that's still your hypotenuse is always the biggest side, no matter what kind of right triangle it is. But do you see that now these two angles are the same? So the sides that are across from them have to be the same. This is called an isosceles right triangle, if you have forgotten what that means. You guys probably have in your head, isosceles means two sides equal. Well, it also means two angles equal, because across from equal sides will always be equal angles. So in this particular scenario, you don't have a short leg and a long leg. You have two equal legs. So maybe you can put these little hatch marks indicating that they are equal. Those are the kind of symbols we use in geometry. Okay, now let me share with you the one and only formula that rules a 45, 45, 90. It goes like this. We don't have two formulas for this type of triangle, just one. Its hypotenuse is equal to square root of 2 times either one of the legs, since both of them are equal. So since the hypotenuse relies on these legs, the legs that are equal, those are the things that you can allow to be any value you want. I'm going to let them be 1. I like the number 1 because it's so simple to do it, use it in your head. So I'm going to let this be 1, and if this is a 1, so's this. Okay, and then I'm going to remember this formula to get this. I just take the leg, multiply it by square root of 2, there's my hypotenuse. But yet I've never used Pythagorean Theorem. Pythagorean Theorem is when you don't have anything special happening inside your right triangle. You don't have a 30, 60, 90 deal. And you also do not have a 45. Then you got to use Pythagorean Theorem. And furthermore, you'd have to know at least two sides. Here you can just know just one and get everything. Okay, so now we are going to use this over and over again the whole semester, all the chapters. Okay, now you see that all of a sudden they're showing you these pictures where the radius is 1. See, if you go from here to here, see how the coordinates right here are x is 1 and y is 0. That means the length of this is 1. And of course, if the radius is 1 going in any direction, it's always 1. It doesn't matter whether you go this way, it's 1, or you go this way, it's 1, or you go this way, it's 1. But now what I want to show you how to do is to start spinning around in this circle. This is called the unit circle. Unit in mathematics means 1. So when we call it the unit circle, that refers to a circle with a radius of 1. Okay, so maybe put that here. This is what we call a unit circle. They will typically mention it in the problem, what kind of circle you're in, because of course not all circles have a radius of 1. Unit meaning radius is 1. Okay, now what you need to get used to is the fact that when I spin around this circle, sometimes I'm going to land here, or here, or here. Do you see these 4 positions I just darkened in? Those are called the quadrantal positions. Whoops. Let's see, how the heck can I fix that? That might be this. Thank you. Okay, so these positions that I just darkened in, they're called the quadrantal positions. So if I tell you to spin to 360 degrees or I say stay at 0 degrees, you will not be able to draw a triangle because you're going to be right on top of one of these axes. If I tell you to go to 90 degrees, so you got to get used to the address of the location that I am telling you to spin to, because it'll be the first thing that starts the problem. You will spin to a particular place. You'll either be able to draw a triangle or you won't be able to draw one. If you can draw a triangle, it'll either be a 30, 60, 90 or a 45, 90. A 45, 45, 90. If you can't draw a triangle, it's because you're either here, 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 and here. No matter where I tell you to spin, you really only need the X, the Y value, and the R value. You see that if you're here, 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 and here, that you already have the X and the Y? And you already have the radius, because isn't the radius on this circle 1? So if I do tell you to go to 0 degrees, there's your X, there's your Y, you already know the R. Because everything I'm going to ask you to calculate, they will be called the Six Trig Functions. And you heard about them in geometry: sine, cosine, tangent, cotangent, secant, cosecant. You'll be doing that the whole course. That's your responsibility to come out of this class knowing how to calculate those 6 values. Now, they do make you do it in geometry, but on a really basic level. They may even teach you something like that phrase SOHCAHTOA that has like all 6 formulas wrapped into one, and we can use that here too. We can use that here, but I'm going to give you more specific formulas that will take you into the more extended cases, but you can always use SOHCAHTOA. You're welcome to use that, and I'll point out what it means again if you have forgotten what it means. Anyway, so if I tell you spin to 90 degrees, again, you won't be able to draw a triangle if you're on a dot that's right on the axis. If you're in midair like this, then you'll be able to draw a triangle. Because when you're in midair like that, like in between 2 axes, what you'll do to create a right triangle is that, remember from yesterday that the side that spins is called the terminal side? So what happened right here is that this side stayed affixed to the x-axis, while that side right there spun. It created an opening. It dug into the circle right here, and right at that dig-in point, you're going to drop down to the closest x-axis. You will travel from that dig-in point on the rim of the circle to the closest x-axis, and that's how you're going to form your right triangle. Okay, we're going to practice that over and over again. This will be our first attempt right here. Okay. All right, so this says, let T be a real number. Let the point P with this X and this Y be a point on the unit circle. So by them mentioning that's a unit circle, that means the radius is 1. Let's see if we have room to do the drawing on the next page. If not, we'll do it here. Nope, we'll do it right here. Okay, so I am going to see if I can draw it. I think I'm going to draw it right here. I have more room. Okay, so this is part A. All right, now when you do these drawings, you're doing the drawings as though you're inside a circle. Now, I don't care if you draw the circle or not. You can if you want to. You can draw the circle. I think I will, just to get you used to me spinning. Okay, so there's my circle. Now look at where you're spinning. Now, does everybody remember, and if you don't, let me remind the people that don't remember, that the signs on the x and the y coordinates, see how this x coordinate is negative while the y coordinate is positive? Those depict what quadrant you're in. There's different ways of me telling you what quadrant you're in. I can either tell you, hey, go spin to 60 degrees, or go spin to 120 degrees. I could tell you that way, and you would know what quadrant you're in. Or this tells you what quadrant you're in, the signs. When you are told the x and the y-axis, you don't have to be told what angle to spin to, because this takes the place. I mean, just like looking ahead, let me tell you that the only reason I would tell you, hey, go spin to 120, is so that you would create a little reference angle, and that reference angle would end up giving you the x's and the y. But since they've already given you the x and the y, I don't need to tell you what angle to spin to because they're trying to start you off with an easy problem where you don't have to spin, draw, figure out the reference angle, and do the x and y yourself. See, they cut through all of that, and that's why they're starting with this problem where they've already given you the x and the y. So let's simply rotate to a quadrant that has a negative x and a positive y. Let's put the signs here for those of you that have forgotten. This is positive, positive, double positives here. This is negative x, positive y. So we're in quadrant 2. By the way, if you have forgotten the names of the quadrants, this is called quadrant 1. Make sure you know these things. This is called quadrant 2. This is quadrant 3. I mentioned this in yesterday's notes. This is quadrant 4. Signs right down here in quadrant 3, double negative. Negative on your x, negative on your y. In this quadrant, x's are positive while the y's are negative. So we are right here. Because of the negative x, positive y, we are in this quadrant. Draw your arm right here. Now you can go beyond the edge of the circle if you want, or you can, if I would have stopped right where the circle was, I would have had a very, very tiny circle. A very, very tiny triangle, excuse me. So you can go beyond it if you want to. Wherever you do stop, drop down to the x-axis. Travel to the closest x-axis, which would mean this one. Okay, drop down, hit it at 90 degrees. And draw a right angle. So you're very clear about what the hypotenuse is and what the legs are. Okay, see this thing that's the x-coordinate? You're going to put it on the leg that looks like a little mini x-axis, which would be the horizontal leg. See this piece right here? That's like a little part of the x-axis. That's where the x-coordinate goes. Put that x-coordinate right there. That's your x value. Now go put this value, the y, on this leg that looks like a little y-axis. So it's y is equal to square root of 3 over 2. They said this was a unit circle, therefore this radius right here is 1, even though I went beyond the circle. I'll have to draw my circles bigger. So the radius is the hypotenuse in these pictures. Okay, maybe you should write that somewhere. The radius is the hypotenuse. Okay, then what they're going to ask you is they're going to tell you to find these trig values. So then what you got to know at that point in order to finish the problem is you have to know either SOHCAHTOA or you have to know how they are defined in terms of x's and y's. So I want you to memorize the x's and the y type definitions, as well as being able to use SOHCAHTOA, because there will be some problems where you won't be able to use SOHCAHTOA. It'll be easier for you to use this. So, see these definitions right here? I'm going to have you rewrite some of them. Let me rewrite them for you. Okay, so here is sine. When you want to do sine of any angle, I don't care where you've rotated to, it's going to be y over r. Your y coordinate over your r coordinate. Cosine will be x over r. And you should try to memorize that cosine always has to do with x. Cosine is the horizontal coordinate. Sine always has to do with y. All right, then there are the reciprocal cousincies. Wait, you're going to have to erase here, sorry. I want you to write these in a certain way. And the reason I'm erasing this and rewriting it is because I want you to realize that even though they've asked you for 6 answers here, sine, cosine, tangent, secant, and cosecant, once you get 3, you really are going to have all 6 of them. So if I write them in the way that I'm about to write them, then you'll realize that. Okay, first of all, sine is y over r. And then there is cosecant, which is the reciprocal. These are reciprocal cousins, the ones that I'm writing next to each other. So if you do get the sine value, just flip it over, and you'll have that answer as well. Okay, so these are reciprocal cousins, sine and cosecant. Then there's cosine, which is x over r, and its reciprocal cousin called secant. Okay, just flip that over. Flip over that definition. Then there's one more pair, the tan-cotan pair. So tan is defined as y over x, while its reciprocal cousin called cotan is represented as the reciprocal, x over y. Now for you to memorize these, to have a real easy time at memorizing these are the ones that you're going to get mixed up. This pair and this pair. You won't get that pair mixed up because it's like a natural partnership, tan, cotan, whereas how are these words related? So, I mean, you can memorize things any way you want. Everybody has their way that they try to get things to stick in their head, their own little mnemonic devices. So, I mean, you could notice maybe this so that you don't accidentally pair up this one with this one. Notice that these reciprocal pairs, both this pair and this pair, the ones that are hard to remember, one starts with an S while the other one starts with a C. That's the same thing of this pair right here. One starts with a C, the other one starts with an S, so you don't accidentally put the wrong two together. So maybe you can memorize it that way. So really, if I was memorizing this, I would only memorize these two. Make sure that I always know cosine is x over r, and sine is y over r, and then who are their reciprocal partners? As far as that goes, the reciprocal partners, one starts with an S, one starts with a C. Same thing here. Because these you're going to find it very easy to remember those. They have to do with the x of just the legs. These all have to do with the hypotenuse. Somewhere in the definition is the hypotenuse. These two formulas don't have the hypotenuse in them at all, because the hypotenuse is the R value, the radius. Okay, let's go for it. We're going to go in here, finish this problem. I just gave you all the rundown on the geometry, how to define these. I'm defining these a little bit easier than this because the S thing might confuse you. All right, so here we go. I'm going to do cosine first. And I'm going to write the definitions every time I do it to help me memorize it. I told you it's going to be a challenge for you to memorize these formulas. So at the beginning, write them down every time you do it to help yourself memorize it. Okay, so let's see. The x value here, you're looking at your picture now. The x is this, divided by the r value, which is 1. So, negative 1/2. As soon as you do that, do the reciprocal cousin. Secant is just a reciprocal of this. Let's flip it over. Negative 2. You got 2 answers so far. Okay, next one, sine. Sine, I'm going to recite the formula to myself. It is the y over the r value. In this particular picture, the leg that goes up and down like a y-axis is your y value. So it's square root of 3 over 2 over 1. And if you want to just jump into square root of 3 over 2 because you know the bottom's 1, you can. I'm just doing it for emphasis. Okay, so this is just square root of 3 over 2. Go and do the reciprocal cousin. Just take this answer, flip it over. Let's talk about your algebra. Now, everybody remember from algebra that these kind of answers are not allowed. You're not allowed to leave the radical on the bottom. It's not considered simplified. So if you want that radical to float to the top, you're going to do what's called rationalizing. You just multiply by this same exact square root, because in the case of square roots, that's what will get rid of the radical. Whatever you do to the bottom, you have to also do to the top. So now the radical's at the top. 2 square root of 3. Square root of 3 times square root of 3 is square root of 9, because you would multiply that. Square root of 9, 3. Any square root times itself is just the number that they have in common. Okay, so that's how that final answer would be given here for cosecant. Okay, I got 4 of the 6 answers. The other 2, I guess I'll put them over here. I might not have room though, so let's see. Do we have any room on the back? Yeah, I'll try to do it here. Okay, so tan. So tan of theta is y over x. Okay, the y value in this case, again, is the leg that runs up and down like a y-axis. So square root of 3 over 2 divided by, I'm going to write it going this way just because we're going to get ready to flip it over anyway. It's y divided by, you know this line means divided by, right? So divided by x. What's my x value? 1/2? Negative 1/2? Okay, now does everybody, I wrote it this way because I knew I was going to have to flip this guy over, and to double stack it one on top of the other, I would have ended up writing it like that. You remember that when you're doing division with fractions? That's the same thing as multiplying by, so change that to a multiplication. It's the same thing as multiplying by the reciprocal of the divisor. Okay, so another way to rewrite this answer in terms of multiplication is leave the dividend alone. That's the first number. Change this to a multiplication. Flip over. You can put the negative wherever you want. On this number, the negative can be at the bottom or the top. The 2's are going to cancel. Cross out those 2's because you got a 2 on the top and also a 2 at the bottom. So those go away. And all you're left with is square root of 3 over 1 with a negative. Okay, so your final answer here after crossing off the 2's is just square root of 3 over 1. And of course it's negative because you have a negative right here. And you can just write square root of 3. You don't have to put it over 1. Okay, cotangent. Where can I squeeze that? Okay, cotangent's going to be the reciprocal of this. So 1 over square root of 3, and it will be negative. I'll write it right here.
So wait, even though you multiplied by the reciprocal, you still needed to add in the negative?
Oh, yeah. Anytime you're multiplying a negative times a positive, it's negative. So you don't just drop the negative. Okay? This is like just arithmetic. A negative times a positive is negative. Okay, it does not go away. A negative times another negative is positive. So cotan here would be, let me abbreviate this. Cotan of theta would be the reciprocal of this. So instead of square root of 3 over 1, 1 over square root of 3. Put the negative wherever you want. I'll put it at the top here. Rationalize. Get rid of that radical that is now in the bottom. And you get square root of 3 over regular 3. Put the negative wherever you want. You can put it at the top, off to the side, or in the bottom. Okay, there's all 6 answers. Negative 1/2, square root of 3 over 2, negative 2, 2 square roots of 3 over 3, and this is tan and cotan. Okay, let's go to the next page. Okay, now I think what I'm going to do before I let you off on your own is I'm going to do one more where I'm going to land in midair and I'm going to do all 6 values. I'm also going to do one where I can't draw a triangle at all. That'll be that 0, -1. And then I'm going to do one where I tell you where to spin, but instead of indicating where to spin by telling you the x is negative and the y is positive, telling you what quadrant, I'm going to tell you in the form of an angle. Okay, so let's go ahead. We'll do this. I'm going to do this one a little bit quicker. What quadrant am I in for a double negative like that? Quad 1, 2, 3, or 4?
3.
3. Okay, so I'm going like this. I'm spinning here. This is my spinning arm, this arm that I'm showing you right here. And I'm just going to go from the edge right to the x-axis. This x goes right here on the leg that looks like an x-axis. That's where you put the x value. And then the other one is, okay, that goes there. This is a unit circle. So that's like that. Let's go ahead and do the trig values. Okay, so cosine. I'll do the cosine first this time. And let me just keep mentioning this because I'm going to get to a problem where it's going to matter that you know this. See how far I spun right here? Because you know you're always, when you start your spin, you're always starting right here. I spun all the way until I got right there with my, because the spinning arm is the hypotenuse. So I stopped right there, right? This, how far that you went to get from here all the way to quadrant 3, that's what we call theta. When I get deeper into these problems, I'm going to have to start talking about the reference angle. That's the little angle inside the triangle, always with the vertex at the origin, because some of you are going to try and draw it hooked up to the y-axis. It has nothing to do with the y-axis. It's the angle between the x-axis and this terminal side called the hypotenuse. Okay, cosine. Cosine is x over r. X value, now you know the sign's going to come out the same. So cosine is the x value, square root of 2 over 1. Yes, this is negative, so that's your cosine. Okay, do the reciprocal cousin right away because it has to do with this. It has to do with flipping it over. So secant, again, one starts with a C, one starts with an S. Just flip this over. So I have one answer called the cosine. Now I have, put the negative wherever you want. I'm just going to keep it at the top to get it out of the way. Can't leave the radical in the bottom, so you're going to multiply by square root of 2 over square root of 2. That's going to give you, I'm going to simplify right here. Square root of 2 times square root of 2 is 2. This 2, now that it's a real 2 rather than square root of 2, will cancel with that 2 right there. So the only thing that's left, remember this is gone, square root of 2 times square root of 2 turned into this. This canceled with this. So the only thing that's left is the negative and the square root of 2. So that's what that rationalizes to. Just negative square root of 2. Okay, there's your second answer. Now you know you're going to get the same thing for sine, right? Because sine is y over r, and the y value is the same as the x value. See, x and y are the same. So exactly what you just got for cosine and secant is what you're going to get for sine. Because the y value would be this over 1. It would eventually turn into that. That's why I'm not going to do it again, all over again. Cosecant is the reciprocal cousin that goes with this. And after doing all of this with the same values as you had here, you would get that same answer, square root of 2. So there's your third and fourth answer. Tan is the y over the x. The tan and the cotan don't use the hypotenuse at all. It's just the legs. So you see what's going to happen here, right? If you go this y over this x, aren't you going to just get 1? I mean, so you could write it if you want to, but you're going to get 1. The y and the x are exactly the same. Anything divided by itself is 1. When you do the reciprocal, you also get 1. Okay, there's all 6 values. Okay, then sometimes I'm going to tell you to go to a location. So far, I have told you to go to locations where I've told you what the x and the y is. And by the signs that were on the x and the y, you knew what quadrant to go to. Okay, now you're not going to be in a particular quadrant. You're going to be in between two different quadrants, and that's called a quadrantal angle. So go to 0, 1 on the unit circle. Okay, you're going to go 0 for your x value, but -1 for your, so you're right here. Okay, that point right there is called -1, 0. So you have your x, you have your y. The radius, because you're in a unit circle, is 1. And you have everything you need to go ahead. You can't draw a triangle this time because you're right on one of the axes. Anytime you're on an axis, do not attempt to draw a right triangle. Just go ahead and go into the 6 values that they're being asked to calculate. So they asked us to do sine, cosine, tan, all the same ones. I'm going to start off with cosine. Cosine, they called the spinning angle T. You can just, reiterate whatever they used. Okay, in any event, I don't care what they call this, theta, beta, alpha, T, it doesn't matter. The definition is still x over r. So the x value is -1, r value is 1. There's your cosine value. Secant is the reciprocal of this. So you flip that over, you're going to get -1 again. Okay, then sine of the spinning angle is defined as y over r, regardless of what that is. Your y value is 0 over 1, which is equal to 0. Then when you go to do cosecant, you flip that over. Cosecant value, undefined. What did you say?
Isn't it 0 -1?
Oh, man. Oh, well. You know what you do to salvage all of this, unless you'd like me to do the problem all over again? Cross that out and change it to -1, 0. There. Now I did a different problem. I picked that one just because I wanted to do a quadrantal angle. That's what that example was about. So since I already did it based off of -1, 0, let's just go with that because we're almost done. Thank you for pointing it out, though. So undefined. And then tan, y over x. So y over x would be 0 over -1, which would be 0. And then when you go to flip it, it would be this flipped over, which is also undefined. So now later when I get to the point where I teach you how to graph all of these functions, you'll see the significance of what it means for something to be, for one of the trig values to be undefined. You'll see what that means in the graph, and you'll be able to tie it all together. But it's some trig values are just at certain locations, they're undefined. Okay, let's go into one more problem, this type of problem. Okay, so now, do you notice the difference in the problems that I'm on right now? That all of a sudden now I'm not giving you an x and a y value, but instead there's an angle there. So now I'm telling you what quadrant to go to, not based on x and y, but based on a spinner. You are going to spin to 3 pi over 2. Now, if you don't know where that is, I'm going to teach you how to count in fractions. At 90 degrees, well, let's talk about this because I want you to get versed in being comfortable with counting in fractions, or else you're going to think you need to convert that to degrees all the time. I mean, for right now, if you want to convert it to degrees, go ahead and do so. You could put a 180 right in there, 3 times 180 divided by 2, and you'll get it quick enough. It's 270. But if you want to try and count in fractions, okay, this is 90. You guys are all really good at the degrees. 180, 270. And this is 360, right? But isn't this also called pi? And isn't this called 2 pi? So would it make sense that to spin from 0 degrees, which is the 360 mark, 360 is just another name for 0. For you to spin from here to here, that's 1 pi, right? Doesn't it make sense that the 90 degree mark is half a pi? So if you wanted to count halves in your head, Every time you pass through a quadrant, you're going another half of a pi. Every single time you go through one quadrant. So watch, you could go like this. This is 1/2 pi, 2/2 pi. Because isn't it true that 1 pi is the same thing as 2/2? 2/2 is the same thing as 1 pi. Therefore, this is 3/2. This is 4/2. I'm just talking about things in halves because that's what they gave you. They gave you halves. So I'm going to try and get you comfortable in counting in fractions and also in degrees. We'll keep going back and forth until your comfort level moves. Okay, so we're down here. Spin all the way to 270. Mark the diagram. That means you're stopping right there. So I was going this way. Okay, what are the numbers here? Again, you're on a unit circle. So that means the radius is 1. So therefore, if the radius is 1, this would be the radius right here. So wouldn't this be known as 0, -1? Because if you're thinking x's and y's, when you're on any point that's on the y-axis, I'm on the y-axis. That's where that point is drawn. Any point that's on the y-axis has an x-coordinate of 0. Because that point is neither to the right nor is it to the left. So it has 0 for an x-coordinate. And as far as how far down it is, this is the radius of this circle. Even though I didn't complete the circle, I mean you could, but that would bear no significance on this problem. You're going from the origin out to the edge of the circle so that your radius is 1. But since you're 1 unit down, it's -1. So that x and y axis is your position. Okay, now you want to do, let's see, what are you being asked to do? Sine, just sine. Now, I was telling you or trying to tell you that when you go to do sine, cosine, tangent, it doesn't matter what's there. It doesn't matter what that angle is. They can have a theta, a beta, a number. It doesn't matter. The definitions remain the same. Sine is always y over r. Every single time you go to do a sine value, it's y over r. That's all they've asked you to do. The y value here is -1. The r value is 1. By the way, maybe you should put this and circle it. Your radius, your hypotenuse, your radius, because you know the radius is the hypotenuse when you can draw a triangle. That r value is always positive. Okay, there are certain things that are always positive. Maybe put that somewhere so that you don't accidentally ever use a negative for your r value. Okay, so it's y, -1 over r, -1. They didn't ask you to do all 6, just one of them. All right. Now, just so I can get you to understand reference angles, I think I am going to let you convert this to degrees. I want you to plop a 180 right in there, multiply it by 5, and then divide by 6. Tell me what this angle is equal to. What is it? 150? Thank you. Everybody know how to get that? Because you know you can always fall back to degrees if that's where you're comfortable. That is what you're going to be comfortable with at the beginning. Okay, all we did, this is from section 6.1. You want to convert to degrees and you're starting with radians, you just put a 180 in there. All right, we are going to twirl to 150, spin to 150. What quadrant are you in if you spin to 150?
2.
Okay, this is my first stab at reference angle. I'm spinning to 150. The reason you know that you're at quadrant 2 is because you're using certain landmarks. You know that by the time you get right here, you're at 180. So you stop before that, draw your little arm right here, drop down to the x-axis. Okay, now let's see if you can understand this. Okay, I was spinning. Spin, 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 spin. I stopped right there. if I would have went all the way, if I was going to make it all the way to 180, and you could even do this. On the diagram, you could go like this. You could extend this and put that you were at a theta of 150. You stopped at 150. How many more degrees would have gotten you from here to here?
30.
That's your reference angle. I'm going to do this, reference angle, and I'm going to put a 30 right there, 30 degrees. Therefore, if this is 30 degrees right here, doesn't that up there have to be 60? So aren't you in a short leg, long leg, hypotenuse type deal? You'll always be in one of these triangles, either 30, 60, 90 or 45, 45, 90. So you have a 60 degree right there, a 30 degree right there. Across from the 30 will be the leg called the short leg. Across from the 60 will be the leg called the long leg. Everything is based on the short leg. You will always let the short leg be 1. And then these other two pieces, the hypotenuse and the long leg, are based on the short leg. They are formulas that you should memorize. You should memorize that your hypotenuse is double that. Always in a 30, 60, 90. And make sure you put the 1 in the proper place. Always across from your 30 degree angle, travel through the triangle and over to the opposite side, and you are standing on the short leg. That is the one that you should let be the 1. Okay, this hypotenuse is double whatever the short leg is. The formulas are written on the first page if you need to keep looking at them. Long leg, short leg, times square root of 3. 1 multiplied by square root of 3, square root of 3. Okay, let's put some signs on these things. When you are in this quadrant, remember something. This leg right here represents the x value. Aren't you in territory over here where the x's are negative? This guy represents, see this little piece of the triangle? Looks like a little tiny x-axis, like a little piece of an x-axis. It is the x-coordinate. And you should label it until you get used to it. This is the x-coordinate. X's when you're over here are negative. This represents the y-coordinate, the one that you see right here, and you're in a quadrant where the y's are positive. Everything in this quadrant has a positive y value. So that is positive. This one is negative. Now do the problem. So this is your first little attempt at figuring out what the rotator angle is. That's this right here. 150. The resulting reference angle is 30, and the reference angle is what depicts every value around the triangle. It tells you what the short leg is, the long leg, and the hypotenuse, just from the reference angle. So if you are not good at reference angle, you will not be good at this class. It is the most important thing in the entire class because it will pop up in every single chapter. So we're going to really hit on that a lot. Okay, so finish the problem. Tan is the y value over the x value, regardless of what you see sitting here. This just told me what quadrant I was in so that I could build a triangle. Okay, y value, come to the picture. Your y value is the leg that goes up and down like this, which has a value of 1. The x value is the piece that runs like this, like an x-axis, which is square root of 3. Yes, it's negative. You can float the negative to the top. Don't forget to rationalize.
You can't see it.
Do you really need to? I'm just kidding. All right, so it's square root of 3, square root of 3. Square root of 3 on the top, 3 on the bottom. Float the negative to the top if you want, or leave it on the bottom. Yeah.
Now, how did we get 1 as the y value?
1 as the, because you are arbitrarily always picking whatever you want for the short leg.
Okay.
And then calculating the long leg and the hypotenuse based on whatever you've chosen. So if you want to, you could let the short leg be 1/2. If you're into big numbers, let it be a big number. You'll still get the same final answer, but if you don't choose a 1, you'll just have a harder time simplifying things. Okay, so your choice. Okay, ready again? Let's try this. I was going to give you time, and I will give you time. I know I've said that twice. It's just hard to get started because I have to show you all these little extra things. Like today was the attendance, and I'd rather get you good on this so that you can go through this easily. Okay, let's try again. Why don't you go ahead and convert that to degrees. Go ahead and plop a 180 right in there for pi. Multiply by 2, divide by 3. Tell me what you get.
120.
120? Okay, so this turns out that we are trying to do the secant at 120. That means we need to spin to 120. Here's my picture. Okay, so I'm going to go 120. I know I got to stop in here somewhere. You don't have to be exact, but you do have to stop somewhere past 90, but before 180, right? Okay, draw an arm. I'm going to make this a little bigger so you can see it. Travel from the edge of this rotating arm. This is your theta. You rotated to 120. So you're at 120 right here, and at the edge, just go to the closest x-axis, which would be this one. Okay, so we're in quadrant 2 again. Now tell me what the reference angle has to be. If we went 120, what's left in there? 60 degrees, right? Because what this arm right here, so if you don't want to put the 120 there, you can put it right here. That arm rotated to 120. So if that makes more sense to you to just extend this arm and realize that this rotating arm spun until it got to 120, the difference between 120 and 180, just subtract in your head, is 60. That would have gotten you all the way to 180. So therefore, it is the reference angle. Okay, therefore, what is the little angle at the top?
30.
30, because you know that this plus this has to be the other 90 degrees. Therefore, the only thing that's really changed in this problem, you're still in a short leg, long leg hypotenuse scenario, but now the short leg is this piece, right? Because always across from the 30, the smaller angle is the smaller side, called the short leg. So now, in the previous problem, this piece right here was the long leg. Now it's the short leg. While across from the 60, this piece right here is your long leg. Don't forget, anything that runs horizontally, any leg that runs horizontally is considered your x value. Any leg that runs up and down vertically is considered your y values. We are in a quadrant where x's are negative. So whatever you decide for the value, it is going to be negative. You might want to put that right now. So this is going to be a negative value. Okay, now, you were saying, where do you get the first value? Arbitrary assignment. You let it be whatever you want, but it's the short leg that you should pick for, because everything else is based off of the short leg. The easiest number I can think of to use is the number 1. But you go ahead and use whatever you want. Just don't use anything negative. Okay, so where's my short leg? Right here? So I'm going to call this 1. It is negative because of the quadrant that we're in. Everything else is based off of the short leg. Okay, so if you double up the short leg, double this value right here, you have the hypotenuse. Now, do you remember me telling you that the hypotenuse is never negative? So don't just blindly go 2 times negative 1. Hypotenuse is always positive. Keep writing it until you get that ingrained in your head. The y value, which is the long leg is square root of 3 times the short leg. So square root of 3 times 1. Now those can be negative. See, the legs are the things that are allowed to be negative, never the hypotenuse. Okay, maybe put that again. The hypotenuse, which is the r value, always positive. It's the only thing that's always, well, the reference angle is always positive also. All right, so this is going to be square root of 3. Y's are positive in this quadrant. And we're doing secant. So secant of 120. Now when you go to do secant, you might want to just think of, what's a cosine? Isn't secant the reciprocal cousin to cosine? So a lot of people in their mind, they temporarily think of what would cosine be, because those are the ones that people really tend to memorize, the sine and the cosine. And then they just flip it over real quick. Okay, so let's see. If I was doing cosine, which is the reciprocal cousin to this, that would be -1 over, let's see, it would be x over r, so it would be -1 over 2. So flip that over. Instead of x over r, it'd be r over x. So r is 2, x is -1, final answer. They only asked you to get one of the values, just the secant, not all 6. Okay, one more. Okay, I'm not going to do all of these, but since there's a negative here, I want to run through this with you. This says go to pi, but rotate in a negative fashion. So instead of going like this, counterclockwise, you're going to drop down from the x-axis. You're going to spin from the x-axis, dropping down as you do so. Okay, I'm going to go this way this time. All the way to pi. It's just called negative pi because of the direction that I allowed my pencil to spin in. I'm spinning clockwise. That's from section 6.1. Okay, when you get here, you're at 180. Okay, you could also call it 180 degrees, -180. Or you could call it negative pi, same thing. I don't care which one of those you call it. You are at, remember, you're in a circle. I only drew half the circle, but still. It has a radius, right? Every circle, whether it's half a circle or a whole circle, has a radius. So isn't this the radius from the origin out to the edge? That distance is 1. But since I'm over here, I'm right here. This is my stopping point. Maybe color that in with a dot. This is where I stopped, right here at negative pi. I'm 1 unit that way. That means my x-axis is -1. And this particular point is 0 units up in the air. Because I'm on an axis, I cannot draw a triangle. But you don't need to because you already have the x, the y, the radius we know to be 1. Radius is always positive, and those are the only 3 things you need to get any trig value, an x, a y, and an r. So sometimes you can't draw a triangle, but it doesn't mean that you can't do this stuff. Okay, so this would be y over r. This would be the reciprocal. That's why I put these side by side. So y over r is 0 over 1, 0. When you flip this over, you get 1 over 0. It is not equal to any value. It's undefined. Okay, coming down here, x over r is the definition. Okay, my x value is -1. My r value is 1. Turns out to be -1. Secant, flip this over, you still get -1, etc. Let's move to the next page. Okay, before I try to do anything from E, get in your calculator and just make sure that you understand that there are different modes. Like for instance, right here, do you see that? You can see very plainly that you're in degrees, right? So the mode needs to be in degrees there when you go to tap that in. Here, do you see that there's no degree symbol? Any kind of a decimal, whether it's written as a pi, you know pi is a decimal, right? 3.14, on and on and on. So whether it's written in pi form or straight out decimal form, pi numbers and decimal numbers are considered radians. So if you were going to put this in the calculator, it would have to be in radians. So let me tell you how to plug things into your calculator that you don't actually have a key for. Like like cosecant, you don't have a key for that. Okay? All right, so make sure you're familiar with the mode key. Here it is right here, mode. I'm in radian. I'm going to do a degree problem first, so click over, click, Get it blinking on the thing you want, press enter. Now quit out of there without erasing your choice. Second, quit. Okay, you're in degree mode. You're doing cosine of 48. So cosine 48, take it to whatever they tell you to go to. They have told you to go to 4 decimal places, so 0.6691. Just write that. I'm not going to switch back and forth. 66. Okay, cotangent. Let me switch over so you can see what I'm doing. Okay. All right, so I'm doing cotangent, but you see the numbers in radians. So go to mode, choose radians, enter to make the choice, and then quit out of there. Second, quit. Okay, now I'm going to do cotangent of negative 6.1496. So let's see, do we have... Okay, so you could do this. Cotangent is reciprocal to what? What is it the reciprocal of? Tangent, right? So do you know that one way to write a reciprocal is 1 over whatever it's the reciprocal to? So we could write it on our paper like this, and then we'll press it in. That this is equivalent to 1 over, this is another way to write a reciprocal. Instead of having the answer and then just flipping it over, you can go 1 over whatever this is the reciprocal to, and then the number goes right here. Okay, press it in your calculator like that. You're already in radian mode. Okay, so it's 1 divided by, and then tan of negative 6.1496, close it. Okay, and we're taking it what? 4 decimal places? So 0.4413, 7.4413. That is all I have time for today. So, my videos will be starting with part E, okay? And I'll put all the videos online today. Have a beautiful day.
You too.
Thank you.
Feel better.
I hope so. This goes away. She gave me a bunch of remedies that I need to try. My hot tea, lemons. I'm going to go home and take care of myself instead of running around.